Okay then, in the previous video we looked at Hooke's law and we essentially defined Hooke's law as a proportionality law. Now, on the graph you see behind me, this perfectly obeys Hooke's law. But what happens if we continually add mass? Well, it doesn't go to infinity, it doesn't just keep expanding to infinity linearly. We would observe something slightly different. So essentially what we've got here is an elastic portion of this graph where we've got force directly proportional to extension. So we could say that up to this point right here, it obeys Hooke's law. So if it obeys Hooke's law, it means that force is directly proportional to the extension that we observe. But what happens if we go beyond that? Well, what we start to observe is something like that, where eventually what's happening is we're going to get, I'll just draw that a little bit better, we're going to get a situation where it's no longer following a standard linear projection. We're getting a curve coming off there. Well, why that is because, like I said, it's no longer obeying Hooke's law, but it's entered what we call plastic deformation. So this is plastic deformation. And you will definitely observe this in springs. If you put too much mass on it, you'll start getting a non-linear relationship. And at that point, you will have permanently deformed the spring also. So Hooke's law is no longer being obeyed. But the nice thing is that if you were to release that tension or compression, what we get is we get a situation where the material property is still the same. And as you release it, what you likely observe, say we were to stop adding force there, what we'd likely observe is something like that. Now, an important factor that you can see there is that the gradient of these two lines is the same, because it's an intrinsic property of the material. So we would expect that to have the same force constant. Right, so we've looked at what happens when we have put too much force on. Let's look at variations on the force constant. Well, what happens then if we have two springs side by side holding a mass? And what happens when we have two springs in series holding a mass? So this is in parallel, and this is in series. Now, you might have an idea of what might happen to the force constant here. It does change. Now, what you'd expect to see on the graph, so if you have one spring, then what we'd likely observe is one of these arrangements is going to be stiffer and therefore have a lot greater force constant, and one is going to be less stiff and have a smaller force constant. So one of these arrangements is going to have a smaller force constant or a larger force constant, smaller or larger. Now, in the experiment, we're going to look to see which is which. Which is this? Is this the parallel arrangement? Is this the parallel arrangement? Or which is the series? And we'll look to find that out in our practical that we're going to do, and how that affects the force constant, and come up with some nice rules for that. Do some research, have a look, and we'll deal with that experiment when we come to it in class.